Hi, today we're going to be exploring the weird and wonderful world of ultraviolet radiation. But before that, roll the intro. Ultraviolet, often referred to as UV radiation, is a wavelength of electromagnetic radiation. UV is not all that dissimilar to visible light, with long-wave UV having waves only slightly too short to be part of the visible spectrum. With shorter wavelengths, we have an increase in energy. The comparatively high energy of UV can make it quite dangerous. Ultraviolet radiation from the sun is what causes sunburn and even skin cancer. Fortunately, a clever invention was developed in 1938 by Franz Greta to block UV from reaching the skin: sun cream. If we take some sun cream and draw a picture with it on a piece of paper, it is barely visible. However, if we shine an ultraviolet torch onto this piece of paper, it is clear to see. This is due to it being an organic carbon-based sun cream, which absorbs UV instead of it being absorbed by the skin. There are, however, also synthetic sun creams which reflect UV, but the effect is much the same. UV does have its benefits, however. Many animals, including humans, require UV in order to metabolize vitamin D, which is in itself necessary for the absorption of calcium. Some animals which are especially vulnerable to this, such as diurnal lizards, can even develop metabolic bone disease if not provided with adequate UV. The energy of UV also has some other interesting properties, such as causing fluorescence in certain materials. Here we have a UV torch being shone onto a dark piece of card. We can see some purple light being reflected from the longer wavelengths of light, which just about enter the visible spectrum. However, when we place this yellow highlighter lid into the light, it begins to glow a bright yellow. What's happening here is that the energy is being absorbed by the lid and re-emitted as a longer wavelength of light which we can see. There are many compounds which have the property of fluorescence. A surprising example of this is actually tonic water. Which will fluoresce light blue due to the presence of quinine. However, some compounds will actually take this a step further and hold on to that energy, slowly re-emitting it as light. This is called phosphorescence. This is most commonly seen being put into glow-in-the-dark toys and stickers by using zinc sulfide with a copper impurity. Here we have some phosphorescent beads. We are going to charge them up, for lack of a better word, with our UV torch. If this was fluorescence, we would expect any light from them to stop as soon as the UV was removed. However, as we take the torch away, the glow from the beads remains, and then slowly fades away. And sadly that does bring us to the end, but thank you very much for watching. I hope you enjoyed. Join us next week for the Global Science Show, where we'll be showing you how to make a small rocket at home. But aside from that, thank you very much once again. Please do share, like and subscribe, and carry on learning. Bye!